Here we go. We're going to use ViaCad to generate a model of a simple mold. I'm going to show you a trick or two that I use to get good boundary geometry as I'm going along. This isn't necessarily how I would specifically make a mold that I'm going to use today, but it's a good way to show the basic principles. We're going to use what's called the lathe tool or the rotate tool and create a solid. Alright, obviously that isn't a model of a mold, that might be a model of something that comes out of a mold. So, let's go back to the top view. And extrude a solid. I kind of like working from the top, makes it easy for me to keep track of everything. Alright, now we'll do a simple Boolean subtract of solids. We're going to subtract from this solid, and this is the solid we're going to subtract. And there we have the model of the mold. Now, we're going to export this as something that CamBam can use to generate toolpaths. Export, STL, test mold. Do you want to replace it? Yes, because it's just for testing. And then here's a little trick that I use to get good geometry for outlines when I get into CamBam. I will select this, extrude a surface 1/1000th of an inch thick off of this face. Then I will select this face, hide it, select this, which is actually a solid, even though you may think that it's a surface. It's a 1/1000th of an inch thick solid, but we're going to use it for a little trick in CamBam now. We're going to export that, export, selected only, OK, test mold, outline. And we're done with ViaCad. We're going to open CamBam. And we're going to create a couple of layers, new layer, new layer. And we're going to make this one where we're going to put the mold. We're going to make this one where we're going to put the outline. And we're going to make this one where we put the outline lines. And you'll see why I did that in a minute. It helps to keep things that are significantly separate on separate layers so that you can hide them and reveal them as needed. Alright, test mold. I'll put that in the mold layer. Test mold outline. And we'll put that in the outline layer. And then we're going to hide this so that it doesn't confuse anything. We're going to select this, edit, surface, silhouette. Doesn't really matter since it's 1/1000th of an inch thick. We're going to get two polylines. Alright, we can hide that. And now we have an outline of our block and an outline of our mold cavity. Very convenient. Show the mold. Select this. 3D toolpath generation. Now the first thing that I'm going to do so that I don't lose track of everything is come down here to the boundary method, and we're going to collect selected shapes. And remember those outlines we created? Alright, there we go. And we'll come back to here and we'll start setting up the tool paths. We'll start with the basics. Tool diameter 0.25, and the tool number, if you're using tool numbers for tool changes in your tool path, and it's going to be a ball nose end mill. Okay. Now there's a lot of things you're going to set up here for speeds and feeds and depth increment and so on, but what I'm going to do is set it up as a single pass to full depth so that you can see the tool paths that it generates. When you set 0 depth increment, it just goes to full depth of the surface. Now there is something that's fairly important right here. See this figure, resolution? Right now that means 20% resolution. That means for a linear distance parallel to Z, it's going to check for the accuracy of the depth every 20% of the tool diameter. That's very important. At this figure, it can leave a fairly rough or jagged finish, but it would calculate fairly quickly. If we increase the resolution to 1%, it would give very good resolution, very little jaggedness to the cut, but it would take a long time to cut the tool paths. So let's go back to 20% for right now, 0.2, and hit Control T and see what kind of tool paths we get. And let's hide the mold and look at just the tool paths. There you go, basic mold. Now, if we didn't want it to cut in that direction, we could set it up to cut in a different direction. See right here it says horizontal. You can set it to vertical, and it cuts in that direction. And you get a basic idea of the paths that your cutter is going to take to cut your mold. If you wanted to cut it out a little bit at a time, say you're cutting aluminum, and obviously you can't plunge 1 inch with a 1/4 inch ball mill into aluminum, you would go down here to where we had set 0 in depth increment and set something reasonable, like 0.1. Now it's going to take quite a bit longer to generate the tool paths. Well, given the light resolution, maybe not so much. But it's going to cut every 1/10 of an inch until it reaches the full depth and makes that final pass. And you still have your mold shape. For a fairly simple mold like this, I would probably rough it like that, and then I would make 2 passes at a finer resolution, and one in the horizontal direction and one in the vertical direction. Simple way to do that is copy your existing machine operation, paste it twice. Okay, we'll do that one again in vertical, but we will set the depth increment back to 0, since we don't have any need to remove the material we've already removed. And we'll come down here to our resolution and set it to, say, 0.05. And then we'll come down here to our step over and set it to something like 0.05. And that is not a dimension, that is a percentage of your cutter diameter. Both resolution and step over are calculated as a percentage of your cutter diameter. We'll turn that one off. We hit Control T. And now you have your fine, smooth cut of your mold. Nice and straightforward. If you wanted to clean it up a little bit more, you might take the same, actually we delete this one. Take this same one, Control C, Control V, and change it to horizontal, and we take a pass in the other direction to clean it up a little bit more. Alright, and you can look at the difference in the tool paths after you've generated them, just simply by turning the mop on and off. There's your horizontal finish, or your vertical finish. There's your horizontal finish. And if the red lines are the rapids between cut paths or between tool paths, and if they're in the way of your view, you can simply turn off viewing those. Right here where it says Show Rapids, you click that. The little yellow area shows where each cut starts. So if that was an issue, you'd simply go up here and put Show Direction Arrow off. Now it's showing your tool paths, and if that's not good enough, you can just hit the plus key and zoom in and see what you got. Okay? And there's your horizontal cut. And that's about it. I'd show you a simulation, but CamBam doesn't have a simulation tool built in. Still, by being able to inspect all your toolpaths like that, you can get a pretty good idea of what's going to happen with your work.